All right, so in this video, we're going to see basically just some more examples of solving rational equations. Just to recap what we've done so far. For a rational equation, the first thing we need to do is check and see what values the variable won't be able to be, because we have to exclude division by 0, so we check the denominators of each fraction, say where is that fraction's denominator equal to 0, and that will allow us to exclude certain values of the variable. Then we find the LCD of the denominators we have, and then multiply both sides by that LCD, which clears the fractions out, and then we're able to solve the equation using methods we learned earlier. Okay, so here, the first thing that I would do is factor that denominator on the left-hand side, because we want to be sure of what x's we're excluding. And it looks like we're going to be excluding 2 and 5. So let me just make a note of that. So x is not equal to 2, x is not equal to 5. And our LCD is going to be x minus 2, x minus 5. Okay, so then we're going to multiply both sides of our equation by x minus 2, x minus 5. So I've done the left side, and then for the right side, it'll look the same. This is one of these processes in math where if you actually write out all the steps, it looks like it's more work just because you have to write a lot, and it gets bigger instead of smaller right away. But that's okay. If it helps make it so that you get the right answer more often, then it's worth doing that writing. Okay, on the left side now, we'll see that the x minus 2 and x minus 5 both divide out, leaving x plus 13. On the right side, when we distribute the x minus 2, x minus 5, the x minus 5s will cancel. We'll be left with 6x minus 2 minus, and then on the last term, the 4 over x minus 2s, the x minus 2s will cancel, left 4x minus 5. Okay, so when we've successfully eliminated all of the fractions, so then as before, we will distribute to remove parentheses, and then combine like terms on the right side. And it looks like x is going to be 5. So let me take x from both sides, and then 8 from both sides. And it looks like x is 5, but that was one of our exclusions, right? We said at the very beginning that x cannot be 5 because that was one of the denominators present in our original equation. So the conclusion to make here is that there's just no solution. So you can just write out the words no solution. You could write an empty set either as curly braces with nothing in between. The symbol for the empty set is kind of a fat 0 with a line through it. If you're using like an online software like My Open Math, then there's a multiple choice, right? You can either select one thing where you've entered the answer, or the other option will be no solution. And so you would just choose no solution in that case. Okay, so that's kind of unsatisfying after all that work, but that's how it goes. Not every equation has solutions. So there's that. So let's try this again. So now this equation has 3 terms in it. As before, we will go through and note what values of the variable need to be excluded. So it looks like x just can't be 0 in this one. And the LCD for 9x and 3x and 18 looks like 18x. So we're going to multiply both sides by 18x. Okay, so then distributing on the left side, the 18s will go away. We'll be left with x squared. In the second term, 18x divided by 9x is 2. We'll have 2x plus 6. And then on the right side, 18x divided by 3x is 6. We'll have 6 times 2. Okay, so a little bit of cleaning. We'll have x squared, 2x, and 12. The right side is 12. Taking the 12s from both sides, we'll have x squared plus 2x. And then we can factor out that common factor of x. We'll have x plus 2 is 0, so that either x is 0 or x is negative 2. So there's two potential solutions, but we saw that our exclusion at the very beginning was that x is not able to be 0. So our only true solution is going to be negative 2. So that's our one actual solution. The other one, the 0, is called sometimes an extraneous solution, which is kind of a funny name because it's not actually a solution, so I call it one, but it's called an extraneous solution. And that means that it's a solution that kind of looks like it might be, but it doesn't end up actually being a solution, okay, when you check. It's a solution to the quadratic equation, the one that's marked with an asterisk right now. It's a solution to that one, but not a solution to our original equation. Okay, so here's another one to try. We have x over x plus 4 equals 32 over x squared minus 16 plus 5. So for this one, go ahead and pause the video, try it yourself, and then restart the video and see how you did. All right, so this is how I've started. So the first thing I did was I rewrote the equation factoring that second denominator. And then we'll note that x can't be 4, x can't be negative 4. And our LCD then is going to be x plus 4, x minus 4. So I'm multiplying both sides by x plus 4, x minus 4. The fraction on the left, the x plus 4's cancel, leaving us with x minus 4. And then for the right side, distributing the x plus 4, x minus 4, we'll see that in the first fraction, the 2 go away. That will leave us just with 32. And then the 5 gets multiplied by x plus 4, x minus 4. And that's how it looks without the fractions involved. So what we're going to do next is distribute to remove the parentheses on the left side. And then on the right side, we'll go ahead and multiply out the conjugate binomials using the difference of squares formula, and then at the same time, multiply in the 5. So this will give us 5x squared minus 8. Okay, so let me collect all of the terms onto the right side. This will give us 4x squared, and then 4x. And then 80 minus 32 is 48. That's negative, isn't it? Okay. And so then we'll just take out a factor of 4. And then factor what's left. That'll be x minus 4x plus 3. So it looks like our potential solutions are negative 3 and 4. Then let me check our exclusions. 4 and negative 4 were both excluded. So I need to discard the 4. The 4 is extraneous. And so our actual solution is just negative 3. The 4 doesn't count. The 4 is a solution to the quadratic equation highlighted in yellow, but it's not the solution to the original rational equation. Okay, on to our next example. We just have a couple more. So this one is a little bit larger. There are 3 fractions involved with this one. On the right side, we'll see that there's kind of a complicated numerator to deal with. That's okay. Where we'll start as before is factor any denominators we have, look for exclusions, and then multiply by the LCD. So once again, pause the video and try it yourself, restart the video and see how you. All right, so the first thing I did was I factored the denominators. I've got 5y minus 2, 3y plus 2, and then 15 times y plus 2y minus 2. So taking a look then, we can see that our 2 exclusions are going to be 2 and negative 2. And the LCD is going to be y plus 2, y minus 2. So we're going to multiply both sides by y plus 2, y minus 2. And also, I forgot the 15. We need the 15 in there too. Okay, it'll be 15y plus 2, y minus 2 on both sides. Okay, and once again, I realize that that's big looking, but it's going to get smaller here in just a moment. Okay, so then in the left-hand side, the first term, the 5 and y minus 2's will cancel. Then we'll be left with 3y plus 2 times the y that was already in the numerator. 15 divided by 5 is 3. The y minus 2 canceled. We'll be left with a y plus 2 plus the y. Okay, and then in the back, we have 3 divides into 15 5 times. 5 times the 5 that is already there makes 25. The y plus 2's are canceled, but the y minus 2's are left. Okay. The right side, the entire denominator cancels out. We'll get left with 2y squared minus 19y plus 54. Okay, so that's how it looks without the fractions in it. So if you didn't get this far, make sure that you can see where we've got that. And then once again, we'll pause the video and you can see how it finishes from here. All right, so in here, as before, we've distributed to remove parentheses, combine like terms. Here you can see there's a common term of negative 19y on both sides, which I've subtracted. That gives us 3y squared plus 50 equals 2y squared plus 54. Subtracting the y squared from both sides, or the 2y squared from both sides, and also the 50 will give us y squared equals 4. And the 2 solutions to that are 2 and negative 2. But as you know, those are 2 exclusions in the first place. So sadly, it looks like after all that there's just no solutions. So that's disappointing after going through that much work, but that's how it goes sometimes. This one, there aren't solutions to it. Okay, all right, that's the end of that one. All right, so our last task in here is using the same techniques as we've had before to do what's called solve for a variable. In this part, solving for a variable means rewriting an equation so that we have an equivalent but different looking equation where the variable that we're asked to solve for is by itself. So here, the a over L equals W equation, we want to rewrite that so that it says L equal to whatever. And so that's what we're asked to do in this first problem. So we'll proceed using similar steps as we'd had before. So we have A over L. Sorry, that's the wrong pen. We have A over L equals W. And what we did before was we'd multiply both sides to make by something to make it so that the fraction would go away. In this case, we need to multiply both sides by L. So that on the left side, we'll just have an A, and then on the right side, we'll have W times L. We want the L by itself, though, so we're going to divide both sides by W. So it looks like L is A divided by W. And that's the end of it. So the common element here is really that multiplying both sides by something to make the denominators go away. So we're going to try that on this one. Here our exclusion is going to be that x is not equal to -1. And we want to rewrite this so that this equation has x by itself. Notice that this has the variable y in it. So we're not going to get a number for the answer. We're going to get a expression involving y for an answer. But either way, we're going to multiply both sides by 3x plus 1. And that will eliminate the denominator for us. Okay, so then on the left side, the x plus 1s will cancel, leaving us 3y minus 2s. And then on the right side, the 3's will cancel, leaving us 2x plus 1s. Okay, and then here there's two variables, so you have to keep an eye on which one you're solving for. We're solving for x this time, so let's divide through by 2. And that will make it so we just have x plus 1 on the right side. And then finally, subtracting 1 from both sides, we'll finish it. We'll have x equals 2/3 y minus 2 minus 1. Okay, so we've rewritten the equation so that x is all by itself. Okay, last example, and then we're all done. So here we have 1 over a plus 1 over b equals c, and we want to rewrite it so that the a is by itself. So our two denominators are a and b, so we're going to multiply both sides by ab. Okay, and so then on the left side, the a's will divide out. We'll be left with b plus, and then in the second term, the b's will divide out. We'll be left with a. The right side will have a, b, and c. Okay, so we're trying to get a by itself. This equation has got 3 terms in it. Out of the 3 terms, 2 have a's and 1 doesn't. Let's collect the terms that have a's to the right side. And now we want to turn that into single terms. So we're going to factor out that common factor of a. So we'll have a times bc minus 1. And then we can finish this by dividing by the bc minus 1 part to get a all by itself. So a will be b over bc minus 1. Okay, and that will do it. That finishes everything for this section. Let me know if you have any questions, and then have a great day.